morning, this is Ms. Billerbeck, and we're going to talk about 13.2 bar graphs and histograms. So bar graphs visually compare frequency or number of observations of a class. So a class could be, for instance, blue, green, red, brown, or it could be types of candy, things that are not continuous. That would be a class. So in this case, we have number of books, so 5 or 10. And we see, we have about, that could be about 6 books here. We write 6. That definitely looks like a 10. This could be maybe 8 books. And then down here we have about 4. So when we quickly compare our books, we see, we have a lot more green books than we have brown books. And we have a few more red books than we have blue books. So it's a quick way to visually look at our data and understand it better. So we can also represent the data as a stacked or segmented bar graph, and it's useful for displaying two-way tables. So let's say I have boys and girls, and I'm counting the number of scholars. So I want to make sure that I represent the total amount of scholars, but at the same time, how many are boys and how many are girls. And if I have classes of sports, say gymnastics, volleyball, and soccer, I can see, it's pretty even in gymnastics and volleyball and soccer. And I can also see that soccer is much more of a favorite sport than, say, gymnastics. But volleyball is very popular too. So again, it's a quick reference. We can quickly understand the data better when it's visually represented to us. All right, so let's look at the first example. So in this one, we have the sales of coffee and tea at a cafe in 4 hours during the morning. Okay, so we have a number of cups, so up to 40 cups here at 8 a.m., 9 a.m., 10 a.m., and 11 a.m. So fortunately, somebody has already counted the cups, and we have a key over here of coffee is red and tea is green. So when we look at this, we see, a lot more coffee sold at 8 a.m., and 9 a.m., we have a few more cups of coffee, but not too many. And then 10 a.m., it must be tea time because there's a lot more tea sold than coffee. But 11 a.m., it tends to be the same amount of coffee and tea sold. So now let's look at which period was tea sold more. Well, that was at 10 a.m., so the time period was between 10 a.m. to 11 a.m. So that would be the time period that tea was sold more often than coffee. Okay, if we add the total cups of coffee, we see we have 30 plus 26 is 56. Plus, if we round that to 20, that's 76 minus 2 is 74. Plus 20 is 94. So we had 94 cups of coffee. And we can do the same thing with the tea. So 20 plus 22 is 42, plus 27 gives us 69, plus 20 gives us 89 cups of tea. Okay, so on average, a little more coffee is sold than the tea. Okay, but this is a great representation, so we might be ready around 10 a.m. to get ready to sell a little more tea if we were planning our business and trying to be more strategic. So that's one reason why we would use a bar graph. It identifies peaks and it helps us to staff for those peak business periods. Okay, so histograms are very, very similar to bar graphs. But bar graphs, again, are used for classes of data that are individual, like colors, like blue, green, red, and candy bars, types of candy bars, Milky Way, Snickers, Babe Ruth, Nestle's Crunch, things like that. Those are classes that are very separate, and we would use a bar graph. But when we're using a histogram, we would use that for continuous data, such as a person's height, weight, or age. So also with a histogram, our data is going to be represented, and it's going to be touching each other. Okay, so let's then at the coffee one, see how the data does not touch each other. We have spaces between our data. Even though this is one time period, it's very separated. It's separate by a space. But with the histogram, it's continuous data, so we have the data touching, so it looks continuous as well. So the histogram consists of these rectangles, and these rectangles have an area that have to do with the frequency here and the interval width. Okay? So this happens to be weight in pounds. So if we use this, we see, oh, we have about 8 people who are between 100 and 125. Between 125 and 150 pounds, we see we have 22 people. And then between 150 and 175 pounds, we have 30 people. And 175 and 200 pounds, we have about 20. And then 200 to 225, we have about 13 people in our sample. So again, this is a somewhat symmetric or very symmetric representation of data, where we would expect there to be some sort of median or mean in the middle, and then to have pretty equal tails on the data, where it decreases and fewer people are at each end of the data. Okay, here's an example of when we have 50 scholars and they're completing a mathematics assignment. So this is the different times that it takes for these scholars to complete their math assignments. So let's make a histogram. Okay, so we're going to put the frequency on the side. And down here, we're going to do time. Time is independent, and it's usually on the horizontal axis of a graph. So this is going to be time, and let's first do the frequency here. So we have frequency. Now we have to be somewhat strategic when sizing our histogram. So we see we're going to do frequency here, and the biggest number is 17. So let's put 20 up top and split it up in half. So we have 10. Then we'll split this in half again to have 15, and half again at 5. And then this will be 0. Okay, so that's how we make it so it looks pretty even. You just keep splitting them in half. All right, so this column is going to be time, but we see we don't start with time 0, we start with time 30. So what we're going to do, just so that our data doesn't end all over, way over here, we can do a little move like this, which says, okay, there is some time here, but we don't care about that time, so we're going to just do a little thing here that says, okay, there's some time skipped, and we're going to start with 30, 40, 50, 60, 70, and 80. Okay, so now our data is going to be easily represented in here and closer to the frequency axis. All right, so let's look at our data. So for the time period between 30 and 40, we see we have 4 people, so we'd represent about 4 right here. Okay, between 40 and 50, we see we have 9. Okay, between 50 and 70, we have 17. So we go way up here. Okay, and between 60 and 70, we have 12, which is right about here. Okay, and 70, 80, we have 8 people, so right about here. Okay, so again, when we look at the data, we can see, wow, this is pretty symmetrical right here. So we do have a median or mean that are pretty close together right here. So it looks like when we look at the data that most scholars are going to finish their math assignment between 50 and 60 minutes. Oops, I forgot something important. We didn't label this. So this is in minutes. So it's very important to label your axes when you're making one of these. So we have most of our scholars finishing between 50 and 60 minutes, and a few of them were very quick to finish. Might not be completely done, but they finished quickly. So between 30 and 40 minutes, and then some scholars took a very long time, between 70 and 80 minutes to finish the math assignment. So this is a very informative tool for a teacher to use to plan out, well, how long should I give the scholars to for this math assignment? So it helps the teacher plan the time allotted for lessons and for independent work. All right, so that's it for today, and I hope you have a wonderful day. Bye-bye.